I'm facing some connection issue. Okay, my Wi-Fi is not stable. I'm not able to switch on my camera. So we have done till here. So have you practiced the question, Muniba?
Yes, ma'am.
Any doubt from that?
No, ma'am.
Okay. So let me check with the team whether other students will join or not. Then we will start the session.
All right, ma'am.
Okay, so let's just start the session. Let's not wait more for them. Okay, let's just start, Muniba. Let's just start the session. So it was the last preparative method of ketones only. Okay. So this is the method of the preparation of ketones only. It's the last method. First method we have done from acyl chloride, we can prepare the ketones. Okay. Second method kya tha? From nitriles using Grignard reagent. And the third preparative method is from Friedel-Crafts acylation. From Friedel-Crafts acylation of benzene. We can also prepare ketone. Okay, Muniba, please, if my voice breaks in between, please let me know. Okay, because I'm facing some connection issue, network issue. Okay, am I audible, Muniba?
Yes, ma'am.
Okay. So let's see by Friedel-Crafts acylation of benzene how we can prepare the as your ketone. Suppose we just take the benzene and acylation. In acylation, Friedel-Crafts acylation, we use this acyl chloride. Okay, RCOCl. What is this? This is your acyl chloride, RCOCl, in the presence of anhydrous AlCl3. Okay, so what is R group over here? So R is your methyl group, CH3CO group. CH3CO group. So what happens? This chlorine will be removed from here, and you have to attach CH3, this RO, this RCO group to the benzene ring. So you will get acylation will be done over here, and you will get this one benzene, which is attached to COCH3. So basically, you have to attach this group. This chlorine, this is a good living group, so it will left, okay, and you will attach this. The attachment will be there from here, from this carbon, right? From this carbon, you have to attach the benzene. So this is a Friedel-Crafts acylation of benzene. For example, let's take another example. This is a benzene, and if your acyl group is this one, CH3, CH2, CH2, then CO, Cl. Okay, now tell me what will be the product in this case? Anhydrous AlCl3 by using.
Benzene ring with CO, CH2, CH2, CH3.
Benzene ring with CO, CH2, CH2, and CH3. So this will be a product. And in this case, this is your acyl chloride, right?
Benzene.
Yeah, here aryl group is there, right? Benzene ring. So you will remove this one, and from here you will attach to this benzene. So you will get this one, two benzene ring, and in between CO group. Okay, so you will get this product. Hello, Jupiter. Why you have joined so late?
I slept, that's why.
You are not good?
No, I just slept, that's why. I got a
Okay,
very
your voice. Okay. So see, we have started with the Friedel-Crafts acylation of benzene. Okay, so Friedel-Crafts acylation is a reaction in which the benzene undergoes acylation reaction, okay, in the presence of anhydrous AlCl3. And we use acyl chloride, RCOCl. So what we are supposed to do, this chlorine group will be removed, and you have to attach this group, RCO group, to this benzene. So what is RCO group in this first one? So this is your CH3CO group. So you will attach the CH3CO group to this benzene. Okay, and attachment will be from this carbon. You have to attach this ketonic carbon to the benzene ring. Okay, so this is your whole Friedel-Crafts acylation of benzene. Now, next reaction. Okay, so we have completed the methods of preparation of ketones only. Now the miscellaneous preparation, the method of preparation of both that reaction by which we can prepare both aldehydes and ketones, which is for the preparation of aldehydes as well as for the ketones. Now first, in this first method is from alcohols. Okay, in this we have By oxidation of alcohols, we can prepare aldehyde or ketone. Okay. Now, see, if we have primary alcohol, suppose RCH2OH. The primary alcohol will be converted to aldehyde, okay, in the presence of which type of oxidizing agent? Strong oxidizing agent or weak oxidizing agent? Yes, Muniba, primary alcohol is converted to aldehyde. So which oxidizing agent you will use? Strong or weak? We have already discussed this in the alcohol chapter.
Strong.
No, weak oxidizing agent. Right? If you use a strong oxidizing agent, so it will convert into a carboxylic acid, not a aldehyde. So when you're using the primary alcohol, if it is primary alcohol and you have to convert primary alcohol to a aldehyde, you will use weak oxidizing agent. Okay, like either PDC, okay, PDC आप use कर सकते हो, PCC use कर सकते हो, etc. If you have to convert, suppose we just take secondary alcohol, like your R, CH, OH, and R dash P. Okay, so this will be converted to, suppose we just take secondary alcohol. What is this? This is a secondary alcohol. So this will be converted to ketone. Okay, what happens if you are just taking the secondary alcohol and secondary alcohol का oxidation कराते हो by the weak oxidizing agent, so it will convert this secondary alcohol to ketone, further ketone. Okay, so just remember, primary to primary alcohol will give you a aldehyde on oxidation. Okay, and which type of oxidizing agent you will use? Weak oxidizing agent. Secondary alcohol will give ketone on oxidation. Clear?
Yes, ma'am.
Okay, if it is clear, then do this question. Fill in the blanks. First question. You have to run the reagent over here. Or okay, see one question. I'll wait for you. Second question. Simple if I write oxidation parameter. Both is okay, quickly write down the product.
Ma'am, I have a doubt.
Yes, Maneba.
CrO3 is a strong oxidizing agent, right?
Yes.
But we
CRO.
still use but we still use it for primary alcohols to convert into aldehydes.
Yeah, it can also convert the primary secondary alcohol, right? So here you will use secondary alcohol will give the ketones when you use the your chromic acid, CrO3. Right? So this is a strong oxidizing agent, but we can use it to convert to secondary alcohol to ketone. So in the first question, you can also use a chromic acid, CrO3. In the first question, you can also use a chromic acid as a reagent. So it will also oxidizes secondary alcohol to your corresponding ketone.
But it converts primary alcohols to aldehydes as well.
Primary alcohol to, yes,
Aldehydes.
yes, yes.
So why are we using a
So,
strong oxidizing agent?
so in the case of chromic acid, if you are using chromic acid is just a not as strong as your potassium dichromate and potassium magnate, KMnO4 and K2Cr2O7. It is a strongly oxidizing agent, but not as compared to the your potassium magnate. So we can use this also, but if you use the potassium permanganate or potassium dichromate instead of this. So it will oxidize it to the carboxylic acid. Okay.
Yes, ma'am.
Okay, so if you have to convert this one secondary alcohol to your ketone, so you can also use another reagent. Okay, because this secondary alcohol, it will get converted to the ketone by a weak oxidizing agent also. You can also use a weak oxidizing agent. Okay, what about the second case? What will be the product in the second one, Aniba?
CH3CHO.
3CHO. Okay. In the presence of PCC, because it's a weak oxidizing agent. So this is a primary alcohol. It will get converted into the aldehyde. And what about the third one? So here only oxidation is being written on the arrow. You don't know which type of oxidizing agent you are using. Okay, here it is not written which type of strong oxidizing agent or weak oxidizing agent. Okay, so if it is secondary alcohol and oxidizing agent, you don't know whether it's oxidizing, which oxidizing agent, आप strong use कर रहे हो, weak use कर रहे हो. So this secondary alcohol, you have to convert this into a ketone. Okay, secondary alcohol, if it is secondary alcohol, so it will get converted into a ketone. So here OH की जगह पे you have to put double bond O. Clear?
Yes, ma'am.
What about the fourth one? Yes, Jubita will tell me. What is the product in the fourth case? Yes, Jubita. Are you
Butanol.
still slept? What?
Butanol.
Butanol?
Yeah.
Why butanol? Why you are breaking this double bond? You are using the PDC. Okay. You are using the PDC, and PDC is a weak oxidizing agent. And what is this? This is alcohol. Which type of alcohol? Primary alcohol. So in the presence of a weak oxidizing agent, primary alcohol will get converted into a aldehyde. So you have to इस bond को क्यों आप break कर रहे हो? No need to break this bond. You have to convert this OH group to the aldehydic group. So what will be your? This is here. You will attach CHO group over here. Okay, and the carbon will be a part of this one. Okay, you are not exceeding the carbon 1, 2, 3 carbon, and here 1, 2, 3 carbon. The number of carbon should be same. You don't have to exceed the carbon. Okay, so just be careful in this case.
Okay.
Yes, Maniba, fifth one.
Um,
Cyclohexanone. Right, this OH group will be converted into a ketone group. So you will get cyclohexane and here double bond. Cyclohexanone. Is it clear?
yes, ma'am.
Now, if we use a strong oxidizing agent, just like your potassium dichromate, potassium magnate, on primary alcohol, so it will convert the primary alcohol into a carboxylic acid. Okay, if in the question they just give you the strong oxidizing agent, so just convert the primary alcohol to a carboxylic acid, not to a carbonyl compounds. So write down note in the notes, usage of strong oxidizing agent on primary alcohol leads to formation of carboxylic acid. So this was the first method, okay, from the alcohol. Now second method is this is by catalytic dehydrogenation. By catalytic dehydrogenation We can also prepare the aldehydes and ketones. Now, okay, so by catalytic dehydrogenation in the presence of a catalyst, right? So suppose if you take primary alcohol, RCH2OH. So just remember, primary alcohol will give you a aldehyde, okay, and the secondary alcohol will give you a your ketone. Okay, and tertiary alcohol on the catalytic dehydrogenation will gives you a alkene. Okay, why it gives you the alkene? Yes, Maniba. Why tertiary alcohol will give you a alkene on catalytic dehydrogenation? No. Okay, let's see. So first, catalytic dehydrogenation of, let's say, the primary alcohol. So it's a primary alcohol, right? So primary alcohol in the presence of a, because we are just using the catalytic hydrogenation, right? So hydrogenation in the presence of Cu, copper हम use करते हैं, और instead of copper you can also use Ag, silver भी आप use कर सकते हो at 573 Kelvin. Okay, so if on the arrow, if you see this reagent, okay, if here is the alcohol and if you see this reagent, copper and 573 Kelvin temperature, so let's do the catalytic dehydrogenation. What you are supposed to do, one hydrogen will be removed from here, OH, and one hydrogen from this. CH2 है यहाँ पे, one hydrogen removed from here and one hydrogen from here. So basically you have to remove H2 because it's a dehydrogenation, elimination of hydrogen. Okay, the removal of hydrogen in the presence of a catalyst. So when you remove H2, so what we are supposed to do? CH, one hydrogen and one oxygen. So you will get RCHO, aldehyde. So primary alcohol on the catalytic dehydrogenation, right? It will give you a aldehyde plus H2 plus. Is it clear?
Yes, ma'am.
So understand the mechanism, what you're supposed to remove, because it's a dehydrogenation, removal of hydrogen. Two hydrogen आपने remove कराना, one hydrogen from this OH and one hydrogen from here. Two hydrogen remove कराओगे, so you will get this one, aldehyde. Now see, if you have the secondary alcohol, RCH, okay, and here another R dash. Okay, two different alkyl groups is attached, and here OH. So this is a secondary alcohol. So secondary alcohol on catalytic dehydrogenation will give you, this is a second. Okay, so the mechanism will be same. You have to remove one hydrogen from this OH and one hydrogen from here. So when you remove this, you will get ketone over here. R, C double bond O, and this is your R dash plus H2. Clear? Okay, so because it's a, we are just doing the preparative method of preparation of your aldehyde as well as ketone. Okay, so we will not discuss the preparation of alkene over here, but remember, when you take the tertiary alcohol, so tertiary alcohol on catalytic hydrogenation will give you alkene, because in the tertiary alcohol there are more methyl group, more alkyl group, and alkyl group hinders the reaction. Alkyl group hinders the reaction. It shows plus I effect. Okay, due to the plus I effect, here the elimination reaction will be occur. Okay, elimination reaction hoga, and you will get alkene instead of your aldehyde and ketone. So on tertiary alcohol, when you do the catalytic hydrogenation of tertiary alcohol, so you will get alkene, not your aldehyde and ketone. And you can also use silver instead of copper. Silver can also be used. Okay, so this was the first method. First method from the alcohol. From the alcohol, you can prepare either by oxidation of alcohol, or second method is by catalytic dehydrogenation of alcohol. Second method is from hydrocarbons. Second method is from hydrocarbons. Okay. So in this, write on the first one, by hydration of alkynes. By hydration of alkynes. So by hydration of alkyne, you can also prepare the ketone. Now let's see how we can prepare. Suppose we have alkyne. What is alkyne? Carbon-carbon triple bond. Okay. So our carbon triple bond. Okay. Suppose this is a symmetrical alkyne, and we are doing the hydration. Okay. I have water there. So you are doing the hydration in the presence of your mercuric sulfate. Okay. Or H2SO4. Okay. Sulfuric acid in the presence of a mercuric sulfate. Okay. Now, what happens over here when you give this? So here the hydration of alkyne will be there. Okay, so this H2O, what happens? This, because it's a symmetrical carbon, so you can attach hydrogen, because H2 has H plus and OH minus ion. You can attach hydrogen or OH minus ion to any of the carbon, because it's a symmetrical type. Okay, I will discuss what you are supposed to do in the unsymmetrical type. But first, let's see the unsymmetrical type of alkynes. What you're supposed to do, this is HO2. This is a water, right? So what you're supposed to do, one, this pi bond will be break. Okay, pi bond आपने break करना है, and you have to attach the one hydrogen to this carbon and OH to this carbon. Okay, so what happens? What happens when you break one carbon carbon के बीच में ये जो double triple bond है, this pi bond you have to break. Pi bond you have to break, and this carbon should be this hydrogen will get attached to this carbon, and OH will get attached to this carbon. Okay, now what happens? RCH. When you attach this will get CH, and this will be double bond. One pi bond will be break, and so that it will be double bond carbon and this R. Hello, am I audible?
Yes, ma'am.
Okay, I got it correct. So this R, then CH, double bond Cr, and to this carbon, which was attached. So let's see, let's write this OH as like this. This is the OH. Okay. Now just see here, concentrate over here. What happens here? The tautomerization will occur. Okay. Now the question is, do you know what is tautomerism or tautomerization? Yes or no?
No, ma'am.
Okay, see. So tautomerism basically it's a special type of isomerism होता है. Structural isomerism हो रहा है where two or more isomers को हम क्या कहते हैं? Tautomers कहते हैं, and they are interconvertible. They are interconvertible and reversible होता है. Okay, so basically what happens? So this is a, you can see this is a ene. This is a double bond means ene, and what is this? OH. So enol. This is known as enol. So this group is known as carbon-carbon double bond, and with this the carbon OH is attached. So this group is known as enol. So enol will quickly or rapidly changes or convert to the ketone group. It is known as keto-enol tautomerism. Tautomerism basically क्या होता है? This is a dynamic equilibrium exists between the two structures, two isomers. Okay, and they just quickly interconvert through a rapid or reversible process. Okay, basically migration of proton होता है. यहाँ पे migration, the proton migrates. What happens over here? You can see. So this hydrogen, so this is a ene, okay, ene, and this is a ol. This is a ol. So this is known as enol group. So what happens? This hydrogen will get over there. यहाँ पे हाइड्रोजन क्या होता है, यहाँ शिफ्ट हो जाता है. दिस हाइड्रोजन शिफ्ट हुआ है. दिस हाइड्रोजन विल एब्स्ट्रैक्ट दिस हाइड्रोजन, एंड दिस ऑक्सीजन बॉन्ड विल शिफ्ट हियर. दिस ऑक्सीजन बॉन्ड विल शिफ्ट हियर. और आप ऐसे दिखा सकते हो. जस्ट अ सेकेंड. So what happens? This hydrogen shift here, migration of proton. This OH का hydrogen है, this proton, it shift here to this carbon. Okay, and this bond will shift over here, and it will transform into a CH2. What happens when the hydrogen comes over here? It becomes CH2. Okay, and this bond will shift over here. This bond will shift over here, so it will give you oxygen and R group. And this double bond, okay, the pi bond will break. So this will give you RCH2 COR dash. Okay, suppose this is a R dash, so you can write on R dash. So basically, this is a tautomerism. What is this? This is a tautomerism. Tautomerism is basically a conversion of one molecule to another by a proton transfer. So this tautomerism is known as keto-enol tautomerism. Okay, you can see this is enol group. Okay, enol group is basically transform into a keto group. ये कीटो ग्रुप में ट्रांसफॉर्म हो रहा है by a hydrogen shift, by a migration of this proton. So this is known as tautomerism, and this type of tautomerism in which the enol group gets transformed into a keto, or keto groups can also convert into a enol group. Okay, so this is known as tautomerism, or this process is known as, in this case, it is known as keto-enol tautomerism. Keto-enol tautomerism. Both are interconvertible with each other. Clear? Jibita, is it clear?
Yes, ma'am.
Okay. Okay, write it down. Okay, Muniba, is it clear what is tautomerism and what is keto-enol tautomerism?
Yes, ma'am.
Okay. So in here you can write down. Okay, so this was for the symmetrical type of alkyne. Now the question is, if you have unsymmetrical type of alkyne, then we have to attach OH group to which of the carbon? Okay, so here also you will use a Markovnikov addition rule. So here you will use a Markovnikov addition rule. So write down the rule over here. So in that case, OH attacks on that carbon atom which has lesser number of hydrogen atom. Okay, and the carbon that gets the OH. Okay, so basically what happens in the unsymmetrical type of alkyne, you have to attach OH group, okay, because you are doing the hydration. So you have to attach the OH group to that carbon which has lesser number of hydrogen. Okay, and that carbon which gets the OH will transform into a carbonyl compound after tautomerism. Okay, after tautomerism, it will get converted into a either ketone or aldehyde. Means carbonyl compound में वो OH group will be converted. OH becomes carbonyl compound, or carbon, you can write carbonyl carbon after tautomerism. Suppose let's do some questions. Or suppose we have unsymmetrical carbon. Suppose CH3, C, triple bond CH. Okay, and you are using the hydration करा रहे हो आप H2O. Okay, in the presence of H2, Hg2 plus. Okay, so basically you are using the hydrogen mercuric sulfate, so Hg2 plus. Hg2 plus आप use कर रहे हो ion, and in the acidic condition. Suppose you are just using the H2SO4 sulfuric acid or HCl, etc. So in the acidic condition, you are this reaction will occur. Now the question is this H2O, you are doing the hydration. So H2 has H plus and OH minus ion. And this is your alkyne. Okay, so to which carbon we are supposed to attach the OH group? So you have, suppose this is your A carbon, this is your B carbon. Okay, to which carbon you will attach the OH group? So H plus and OH minus. So OH minus group you have to attach to that carbon which has lesser number of hydrogen or no hydrogen. So you can see to the B carbon has only one hydrogen and A carbon has no hydrogen, right? So it's very simple. You have to attach OH to that carbon. A carbon भी आप attach करोगे, right? And the hydrogen to the B carbon. What you are, and you have to break one pi bond, CH3, carbon, double bond, CH2, right? And here OH group, OH group. So OH, let me show it like this so that we can show the tautomers. So what happens here? So this hydrogen, it will abstract this one, okay, and this bond will shift over here, and here tautomerization will occur, and we will get CH3, CO, and one bond, this pi bond will be break, and this CH3. So basically, you will get acetone in this case. Okay, is it clear? Jyovita and Muniba?
Yes, ma'am.
Okay, so please just use the Markovnikov of addition rule and you will get the product. Second, now do these questions quickly. Second question is this. Using the same reagent. Third question is same reagent. Fourth one is your CH, triple bond CH. Same reagent. Okay, just quickly do that and tell me the answer. Remember the steps, what you're supposed to do. Use the Markovnikov addition rule. OH should be attached to that carbon which has less amount of hydrogen. And in your note after this, after doing this question, just remember formaldehyde, HCHO. What is formaldehyde? HCHO. So formaldehyde cannot be prepared by this method. Formaldehyde cannot be prepared by this method. And aldehydes other than acetaldehyde. So you can only prepare acetaldehyde. So by using this process, the hydration of alkyne, you can only prepare the only one type of aldehyde, which is acetaldehyde. Acetaldehyde के अलावा आप और कोई prepare नहीं कर सकते हो. So just remember, aldehydes other than acetaldehyde cannot be prepared by this method. Cannot be prepared by this method. Okay, I will explain you why, but do this question first. When you do the fourth question, you will get to know why you can't prepare the acetaldehyde, why you can't prepare aldehydes other than acetaldehyde. You can only prepare one aldehyde, which is acetaldehyde, and this is the fourth reaction. CH by your ethyne. CH, triple bond, CH. Ethyne, you can prepare the acetaldehyde. Okay, just quickly do that and tell me the answer. Okay, we have very less time. We have to complete this chapter anyhow before 26. Because your exam is on 26, Muniba, right? Sunday, 26th.
Mom, my exam is on 27th.
Okay, okay. 27th. Monday.
Yes.
But just a second. Sana has shared me your exam schedule, and in that I just saw.
No, they changed the dates
Okay,
today.
okay, okay, got. Okay. So if possible, we can schedule some extra class also. Okay, so have you done these three questions? See, if in your exam they only ask you the product, so it's very simple. If they ask you to write on the product, so no need to write on the whole mechanism. What you have to do is, this is your triple bond, this is your alkyne group. First check which carbon has less number of hydrogen. So see 1, 2, 3 bond, it has CH, right? It has CH, one hydrogen. This carbon has one hydrogen. इसके पास क्या है one hydrogen है, and this carbon, you can check, this carbon has no hydrogen, 3 bonds and 1 bond, 4 bonds are already occupied, so it has 0 hydrogen. So what you are supposed to do, just break this triple bond. ट्रिपल बॉन्ड को क्या करना है, सिंगल बॉन्ड बना दो, एंड you have to attach the you have to make this one, this carbon which has less number of hydrogen, ketone बना दो. So basically you have to do this. No need to write on the mechanism if they only ask you to write on the product. If they gave you the alkyne group, unsymmetrical type of alkyne group, in the presence of your Hg2 plus, okay, mercuric sulfate de de, and in the presence of acid, any acid. So what you're supposed to do, just break this bond, okay, triple bond को आपने single bond बना देना है, and you have to check which carbon has less number of hydrogen. जिसके पास less number of hydrogen है, just make them ketone, because first it will make OH group, and OH group will undergo tautomerization and it will convert the OH to the ketone. Enol को क्या करेगा, ketone में convert कर देगा by tautomerization. So no need to write on the whole step in your exam if they don't ask you to write on the whole mechanism. If they only ask you to write on the product, write on the major product, so do that. Okay, so that आपका time waste नहीं होगा, and you can get the product in a very less time. So that's the trick. So in the third one, what will be the product, Maniba?
CH3, CO, CH, CH3.
CH3, here oxygen, because this carbon and this carbon both are symmetrical, right? Both are symmetrical, so you can attach oxygen to any of the carbon. You can attach here also and here also. You will get the same product. And what about the fourth one? So fourth one is your alkyne. Oh, sorry, ethyne. It's a ethyne. So what happens first? This is again a symmetrical type of carbon. So you can attach oxygen, OH group to any of the carbon and hydrogen to any of the carbon. So first step क्या हो जाएगा? This will be CH2. Suppose you are attaching hydrogen to this and OH group to this carbon. So it will give you CH2 double bond and one pi bond. You will break CH2 double bond CH and here oxygen and hydrogen. It will undergo tautomerization, right? And you will get CH3 and this double bond will break CH COH, right? This is a CHO. Now, in all the process, you can see the product is your ketone, but in the last thing, you can see the product is your aldehyde, CHO group here, right? So this is an aldehyde. So aldehydes, you can't prepare more aldehydes using this process. You can only prepare this acetaldehyde, CH3CHO. What is this? This is your acid group. CH3CO is acid group and hydrogen is attached, so this is your acetal group. Okay, and if you have to attach, if you have to prepare other than aldehyde, other than this acetaldehyde, then it will become ketone, not aldehyde. Why? Because here this is hydrogen. Okay, and इस side of फिर क्या हो जाएगा? CH2 and other things CH. Then this hydrogen, instead of this hydrogen, if there will be, suppose वहाँ पे CH3 है, and here instead of hydrogen, if you have to attach CH. Okay, so this become ketone. Okay, so it is no longer be a aldehyde. So you just always remember by this process, okay, by this process, by the hydration of alkyne, you can only prepare acetaldehyde, not other than that. Is it clear?
Yes.
Okay, so that's why I've written here in the second point. Write down these points. Aldehydes other than acetaldehyde cannot be prepared by this method. Okay, because it will give you a ketone instead of aldehyde. Now, the second method, by ozonolysis of, this is again by a hydrocarbon. From hydrocarbon, first method was by hydration of alkynes, and the second method is by ozonolysis, ozonolysis of alkene. What you are supposed to do? We have to do the ozonolysis of alkene. Okay, so write down here what happens. Alkene reacts with, you know very well, ozonolysis में हम क्या use करते हैं? Ozone, O3. So when alkene reacts with ozone gas, ozone, so it first it will form ozonide, ozonide, right? Which further or subsequent cleavage, cleavage with zinc dust, with zinc dust gives corresponding aldehyde and ketone. And ketone. Okay, so what happens in ozonolysis? Because it's a lysis, so you have to break the bond. Lysis means break down, break karna apne bond. So first, when you treat the alkene with a ozone, so suppose we just take carbon-carbon double bond. This is your alkene. When you treat it with ozone, O3, so what happens? What happens in this? It will form ozonide. Now, what is ozonide? So what you're supposed to do, in between the carbon and carbon, okay, you have to attach oxygen here and two oxygen here. Right? So आपने क्या करना है? Basically, this is ozonide, this carbon, okay, this is another carbon, these two carbon. See how you have to prepare the ozonide. This two carbon, you have to break this bond, and you have to, because this is, you have to attach oxygen, one oxygen, and two oxygen here. This is your ozonide. What is this? This is your ozonide. So when alkene reacts with ozone, it will form ozonide. And what is this? This cyclic compound, this is known as ozonide. Now, further, when you treat this ozonide with a zinc dust, okay, with the zinc dust in the presence of water, water be there, okay, hydration bhi kara rahe ho. So what you are supposed to do here, the cleavage of this ozonide will occur. And how the cleavage will occur? So this bond, see this, how you have to break this bond. This. Okay, so this bond will occur CO and CO. 2 moles of carbon ketones will be there, ketone will be formed. Okay, and this oxygen will be removed out, O2 की तरह remove हो जाएगा, and you will get what you will get carbon, okay, and here the double bond plus 2 moles of, when this bond will break, so you can see this यहाँ से break हुआ, this will get carbon and oxygen, okay, this one, and this will get carbon and oxygen. Double bond this. Okay, and you can also write 2 moles of ketone. 2 moles of ketone. So this one you will get. So how the ozonolysis occur? First, you have to treat the alkene. When treatment with ozone, it will give you a ozonide. And further, that ozonide further reacts with zinc dust, okay, in the presence of water and hydration karate, further hydration. So it will give you, the bond will cleave like this, okay, and you will get 2 moles of ketone. Is it clear? Clear or not? If there is any doubt, if you can ask. Hello.
Yes, ma'am. Okay.
Is it clear?
Yes.
Okay, so shortcut मैं समझाती हूँ. Shortcut, here's a trick also. What you're supposed to do, just break this bond, okay, and attach one oxygen to this carbon. जहाँ से आपने break किया है, see this carbon-carbon double bond, right? What you're supposed to do, bond will break, this bond will break, and you have to attach one oxygen to this carbon by a double bond, and one oxygen to this. So you will get carbon double bond this plus carbon double bond this. So this is a trick, and this is a mechanism. Okay, so if you have to write on the product only, so you can use this trick. Okay, now let's do some questions on this. First question, if I give you CH2, double bond CH2. First step O3, ozonolysis करना है, and second step zinc, the presence of water. Okay, now write on the product. Second question, CH2, double bond, CH3. Same. Third, the reagent will be same in all the cases. Just quickly write down the product. Fifth question, sixth question. Here, if I give you two double bond, the mechanism will be same. If you know the mechanism, you can follow that mechanism and you will get the right answer. Okay, now quickly do these questions.
Ma'am, can you explain the second one once?
Okay, second question.
Yes.
Okay, see, it's very simple. What you're supposed to do, this bond will be break, okay? And from where the bond is break, this carbon and this carbon. So you have to attach the oxygen. So here, if you attach the oxygen, so what will be the product? So it will give you CH2 and double bond oxygen, right? इसके पास एक oxygen गया. Plus, this CH will get one oxygen by a double bond. You have to attach via a double bond. This. So this will be your product. Clear?
Yes, ma'am.
Okay, now you can see here, you can write down this like, this is your HCHO. What is this? CH2O. So this is H, C, double bond O and H. So what is this? This is a formaldehyde. Two hydrogen to this carbon and this oxygen. So this is a formaldehyde. And what is this? This is again a aldehyde, carbon, double bond, this hydrogen, and here CH3. Okay, so this is again a aldehyde, CH3, CH2. The trick is very simple. Just break the double bond, okay? And one oxygen to this carbon and one oxygen to this carbon, just attached by a double bond. Okay, so first one again, see, you will get CH2 oxygen plus CH2 double bond oxygen. And what is this? This again CH2 oxygen is nothing. It's a formaldehyde H. Okay, carbon to that carbon, oxygen and hydrogen. What is this? This is a formaldehyde. We do the rest of the question. Jubita, is it clear to you? Why you are not responding?
Yes, ma'am.
Okay, so do the third question number third and tell me the answer. Just tell me the name of the aldehyde. First, just use that trick, what I said. Okay, just step by step do the mechanism and write down the answer and tell me the name of the product. You have to tell me the name.
Ma'am, can you please scroll up?
What?
Can you please scroll up? Because I have completed that two questions.
Okay. Third one again, see what you're supposed to do. Just break this bond, okay? And to this carbon, from here you are breaking this bond, right? So this carbon and this carbon, you have to attach one oxygen via a double bond. Okay, so what happens? This carbon, oxygen. And to this carbon, you can see one, two, three. Three bonds were there, so one hydrogen. So this is again aldehyde. Okay, और आप ऐसे भी draw कर सकते हो, like and this is one hydrogen plus another one also. This is again one, two carbon. Okay, one carbon which is CH3. One carbon has CH3. One carbon has double bond. Okay, oxygen, and one carbon has hydrogen. This has one hydrogen. Okay, so it will give you a 2 moles of aldehyde. Okay, fourth one. Fourth one is again simple. Just break the bond and to attach the oxygen to one carbon to both the carbon. So this is one, two. Okay, and this is zero. Let me attach this slide. So when you attach this, so you can CH3, and यहाँ पे to the between the second carbon, you have to attach the oxygen. So it will give you a acetone. Okay, propanol means acetone. One, two carbon. Okay, and you can see to the second carbon, you have a aldehyde, right? You have a one hydrogen. So one CH3, the second carbon पे you have to attach the oxygen, and to that carbon, one hydrogen is also there. So with this fourth question may you will get aldehyde as well as ketone. Okay, so here you can see you will get aldehyde as well as ketone. This is your ketone and this is your aldehyde. Is it clear?
Yes.
And what about the fifth one? Yes, Maniba, tell me the fifth one.
Pentane with oxygen plus CH2O.
Pentane, it's a cyclopentane.
Yeah.
So you will get a cyclopentanone. So this bond will break, and to this carbon you have to attach one oxygen. So it will give you cyclopentanone plus your formaldehyde. What is this? E, C, double bond, and H2. You will get this one, CH2. And here on this carbon, you have to attach this one. और इसे आप कैसे लिख सकते हो? This carbon has two hydrogens, so you can write hydrogen, this carbon, oxygen, and this. What is this? This is a formaldehyde. Okay, so in your exam, just write on this type of structure. So this is the formaldehyde. So it will again give you a cyclopentanone, okay, cyclopentanone plus your formaldehyde. What about the sixth one? Break this bond. Now this is, see here, concentrate over here. So this is a cyclic structure, right? And in the cyclic structure, there is a double bond. But in the fifth question, the double bond or the ethene, basically alkene was outside the cyclic ring. But here in the sixth question, it is inside. It is inside the cyclic structure. So when you are just breaking this bond, so suppose if this is the first carbon, second, third, fourth, and fifth. The mechanism will be very simple and very easy. Okay, same mechanism you will follow. You have to break this bond, and to this carbon, first carbon and fifth carbon, you have to attach one oxygen. One oxygen because it's a cyclic structure. Okay, if you break this, यहाँ से आप break करोगे, so it will not break into two compounds. You will not get a two compounds. You will get a single compound in this case. Because here, this is a cyclic compound. So यहाँ से अगर break हो रहा है, this bond, 1 or 5, between the 1 and 5, there is a double bond. So you are cleaving this bond, right? So what happens to the first carbon? Just open the bond. First carbon, first, second, suppose this is the first, second, third, fourth, and this fifth carbon, right? So this is a straight chain आपको मिलेगा, and onto the first carbon and the fifth carbon, you have to attach one oxygen, just like this. Okay, just like this. Or, okay, so you can see this is this carbon, this terminal carbon. So this terminal carbon is involved in one, two, three. Three bonds. It means one has hydrogen. One hydrogen is also present to the terminal carbon. So you can also write like this, CHO. This is a CHO. Okay. this carbon, one hydrogen, and this oxygen. So combinedly, you can write CHO, one carbon, two carbon, three carbon, four carbon, and this five carbon. Okay, so this is structure you can write. Is it clear, this one? Sixth question.
Yes, ma'am.
Okay, so you can open this straight chain. And what is this? This is a terminal carbon has one hydrogen. So this is aldehyde group, not a ketone. Okay, ketone is always in the between. So between the ketone, suppose this is a ketone. So on the right and left side, there must be a alkyl group or aryl group. Okay, it will be in center. Ketone हमेशा center में होता है. It is not at the terminal position. Okay, if it is on terminal position, so it's aldehyde. So it has one hydrogen also. Okay, so both you can see it's on terminal position. So this is aldehyde, not a ketone, because it has this carbon has only one hydrogen, not a methyl group or ethyl. So this is the aldehyde. You will get a one compound which is the aldehyde. So whenever if you get a cyclic type of a structure and you have to do the ozonolysis, so just mark the numbers. आप numbers दे दिया करो carbon को. Okay, just mark the carbon first, second, third, and so on, so that it will be very easy to break the bond. And कहाँ पे आपको oxygen attach करना है, it will be very clear for you. Okay, and do the seventh one. Just try it. It is again a different type of question because in the same compound you have two alkenes. Two unsaturation is there. Double bond दो है तो दोनों ही double bond को आपने break करना है. Okay, so let's what you are supposed to do at the same time, just break this bond, break this bond. Okay, and what you are supposed to, when you break this bond, this CH2 group, it will get oxygen, and इस group इस carbon पे भी एक oxygen होगा, and again this carbon. Okay, let's see. So you are first this bond I'm just breaking the first one. So this will get you CH2 and this carbon. Okay, plus. Okay, now I'm just breaking this one. I'm just breaking this one. You see what happens when you break this bond. So CH2, ये group होगा आपको मिलेगा, and this bond, this and this CH2. So इससे oxygen से attach करा दो, इससे oxygen से attach करा दो, and again this carbon and carbon, again it has a double bond. Okay, this carbon is has again a double bond, and this carbon has again double bond. So you have to attach this to this carbon and to this carbon again. The oxygen will be attached. So you will get three compounds over here. Three compounds, three products आपको मिलेगा in this question because you are just cleaving two bonds over here. Two alkene is present. Okay, two double bond is present. So you at the same time simultaneously you have to break these two bonds. Okay, and see if you break this bond, so this you will get this, right? CH2, and CH2 से आपने attach कराना oxygen by a double bond. Now this CH2, when you break this bond, so you will get this one CH2 and oxygen. And what about this one? This carbon and carbon, it is again involved in the double bond. इसके पास भी double bond है, right? This carbon and carbon. So again you will attach oxygen, one oxygen, one oxygen. So you will get three compounds over here. So first compound, and you can also write two, so because this and this is same. The CH2O and CH2O. What is the CH2O means? HCHO. CH2O मैं बोल रही हूँ, it means it is formaldehyde, HO. So 2 moles of formaldehyde you will get. So you can write 2 moles of formaldehyde plus this one. This structure is, this is a double bond, this is a single bond, and you have to attach one oxygen via a double bond like this. Okay, and you can also write this. You get CH2. What is this? 1, 2, 3 carbon. Okay, 1, 2, 3 carbon means here one CHO. CHO, and this is CHO. Okay, so you can write like this. You can also write like this CHO group via CHO group. Is it clear, this one?
Yes, ma'am.
What about you, Jibita?
Yes,
Okay, write it down quickly. Done? Okay. One more question. Suppose we have any reagent, a known reagent. You have to identify this one, R group. In the first step, we are doing the ozonolysis. Second, zinc in the presence of water. Okay, and you will get 2 moles of your hexanone. Now tell me what will be the R over here. Identify R. What will be R? Just think about it. Just reverse the reaction. What we have read till now, just reverse that. We are just breaking the double bond. Double bond को हम break करके we are just attaching the oxygen to that carbon from where the double bond is being cleaved. Right? And you are getting 2 moles of hexanone over here. So what will be the reactant over here? Just think about it.
Hexane with a double bond CH2.
CH2? No. See, yeah, यहाँ पे 2 लगा हुआ. It means 2 moles of your hexanone you are getting, right? So suppose, for example, this is your hexane, right? And here there is a double bond, and another hexane is there. Okay, hexane, and between these two carbon, it is attached via a double bond. So now see, if you cleave this bond, if you cleave this bond, so do you get this one? 2 moles of hexanone? Yes, right? So when you cleave this bond, one oxygen will attach to this one, this hexane, and one oxygen will get attached to this carbon via a double bond. Means it will give you 2 moles of hexanone. So this is your R. What is R? So R is this. So this type of question में क्या करना है? Just remove this oxygen, okay, and just repeat this structure. Okay, just ketone को remove करा दो and just repeat this hexane structure via a double bond. Just attach that. Okay, and after when you just cross check the reaction, when you cleave the bond, you are getting the product or not. Okay, when you cross check करोगे आप, so you will get to know, yeah, your product is same and the reactant is this one. Okay, so see, when you write on the full reaction, suppose this is your reactant. This is your reactant, and you are doing first step में O3 use कर रहे हो, and the second step, I'm not writing the whole mechanism, right? So when you cleave this bond, what happens? You will get oxygen plus this one. It means you can write down 2 moles of hexane. Clear?
Yes, ma'am.
I have one more question, but I will give this question in your homework. So you have to give the name of the reagent for the transformation for the conversion. Okay, so I will give that in your homework. Now write on the physical properties of your carbonyl compound. Physical properties. Okay, write down in the physical properties. Aldehydes and ketones. So aldehydes and ketones are miscible in water. They are miscible in water because they can form the hydrogen bond with water. So aldehydes and ketones, the carbonyl, the CO, because both have CO group. Aldehydes have CO group as well as the ketone has a carbonyl group, the CO group. So this carbon and oxygen, between this one, oxygen has a lone pair, right? So what happens is oxygen can get attached to the hydrogen. Okay, because hydrogen is, you can see this one. Just a second. This is your H2O. This is your water, right? When you dissolve, this oxygen is electronegative, right? So it is partially negative charge, and this hydrogen has partial positive charge, right? So this is more electronegative, this oxygen. So what happens when you add aldehyde or ketones to a water? So aldehyde, both the groups, carbonyl compounds, may this aldehyde and ketones have the common group which has a CO group. Okay, this both have the CO group. So what happens is oxygen has a lone. Okay, oxygen has a lone pair which is negatively charged. Lone pair is it is non-bonded electron. So this hydrogen is electropositive. So what happens? This get attached to this. ये attract करता है, इसे approach करता है this oxygen को, and this is basically it forms hydrogen bond with water. So the oxygen of the ketone or aldehyde, it forms hydrogen bond with water so that they are miscible in water. Okay, because the oxygen of aldehyde and ketones can form hydrogen bond with water. Is it clear?
Yes, ma'am.
Okay, so now write down aldehydes and ketones are miscible in water as the oxygen of aldehyde and ketone can form hydrogen bond with water. Okay, and you know very well, this point is very common. We have already discussed, like in haloalkane, in aldehydes, in your alcohols, etc., that solubility will always decrease on increasing the carbon chain length. When you increase the number of carbon, so the solubility will decrease. Okay, so write down here also the solubility of aldehyde and ketone will decrease on increase in carbon chain length. When the number of carbon increases, the solubility decreases. Okay, now what about the boiling point? So see, boiling point की बात किया जाए तो boiling point of aldehydes and ketones are higher than non-polar hydrocarbon and ester. Okay, because ester is weakly polar, slightly polar hota hai, and your hydrocarbons are non-polar, right? And you know very well the compounds which has hydrogen bonding and your polar, they have higher boiling point. So aldehyde and ketones are polar in nature, right? So due to the polar in nature, they are high. Their boiling point are higher than the hydrocarbons and your ethers. Okay, so write down this point. Boiling point of aldehydes and ketones are higher than non-polar hydrocarbons and weakly polar ethers. When you compare the boiling point of aldehyde ketones with hydrocarbon and the ethers, so aldehyde and ketones have higher boiling point than these two hydrocarbons as well as ethers. इनसे ज्यादा होता है. Now, what about when you compare the boiling point of aldehyde ketones and with the alcohols? Okay, so alcohols are have more boiling point, have higher boiling point as compared to the your carbonyl compounds, right? So write down the boiling point of aldehyde and and ketones are are less than alcohols, right? So they have more boiling point. Alcohols have more boiling point as compared to the carbonyl compounds. For example, if I give you a question, you have to these, arrange these in increasing order of boiling. First one is your CH3, CHO. Second one is your this one. C is your ether, and D is your suppose this one. Okay, now just arrange these in order of the boiling point, increasing order of the boiling. Yes, do it quickly. Yes, Jupiter, tell me the order of boiling point.
First one is C.
First one, C, according to Jupiter. Okay. C has the highest boiling point according to you, right?
Highest A.
Highest will be A. A. Yes, next order batao. No? Ah,
Yes.
tell me the order.
D A C B.
B, A, C, D.
B A.
B, A, C, D. Right? B will have the highest boiling point. Yes, very good. See how she have arranged the boiling point according to the increasing order. See, the CH3CHO, it's a aldehyde, right? Means it's polar. It is polar in nature. And what about this? This has a alcohol. Alcohol के पास क्या होता है? Hydrogen bonding, which is the strongest among all. Okay, if the hydrogen bond is the strongest, means its boiling point will be quite high. The high boiling point of the alcohol is high among all of them. So B, okay, after B, it is polar in nature, then A, okay, and you know very well this ether is slightly polar. It is weakly polar, right? So after A, it will be C, and you know very well this is a non-polar. Okay, this is a hydrocarbon, so this is a non-polar. So non-polar में क्या होता है? The boiling point is quite low. So this is the order of the boiling point. B will have the highest boiling point due to the hydrogen bonding, and D will have the least boiling point due to the non-polar compound. Clear?
Yes.
Yes, Jibita? Okay. Okay, so I stop it here. The time is already done. Now, chemical properties we will discuss in the next class. We have already done with the methods of preparation. Okay, by method of preparation for aldehydes only, methods of preparation of your ketones, and the methods of preparation of both aldehydes as well as ketones. Okay, and after that we have done with the physical properties. So just please revise all the notes